Welcome to myprojectbazaar.com. Now we are going to see about the process collaborative key management protocol in ciphertext policy attribute-based encryption for cloud data sharing. Then comes abstract of our process. Ciphertext policy attribute-based encryption is a promising cryptographic technique for fine-grained access control of outsourced data in the cloud. However, some of the drawbacks of key management hinder the popularity of its application. One drawback in urgent need of solution is the key escrow problem. We indicate that front-end devices of clients like smartphones generally have limited privacy protection. So, if private keys are entirely held by them, clients risk key exposure that is hardly noticed, but inherently existed in previous research. Furthermore, enormous client decryption overhead limits the practical use of attribute-based encryption. So, in this paper, we propose a collaborative key management protocol in CB, that is the Ciphertext Attribute-Based Encryption. So, our construction realizes distributed generation, issue, and storage of private keys without adding any extra infrastructure. A fine-grained and immediate attribute revocation is provided for key updation. The proposed collaborative mechanism effectively solves not only key escrow problem but also the key exposure. Meanwhile, it helps markedly reduce client decryption overhead. A comparison with other representative ciphertext attribute-based encryption schemes demonstrates that our scheme has somewhat better performance in terms of cloud-based outsourced data sharing on mobile devices. Finally, we provide proof of security for the proposed protocol. Then comes the flow diagram of our process. So the flow diagram shows our process arithmetically. So here there are 5 roles in our process. So one is data owner, key authority, cloud server, decryption server, and also the client. So here data owner will be store the data in the cloud, and the client if satisfy the attributes, so the client can get the file of the data owner. So first let us see about the data owner process. So here data owner is the authorized person. So he only selects the data and uploads it into the server. So using attribute-based key, data owner will encrypt the data and send to the key authority. So the key authority also has a separate authentication. Key authority views the request and update the key. Here key authority will generate the key and break the key into 2 parts. And also by using the key he re-encrypt the ciphertext. So that becomes the ultimate ciphertext. And also key authority breaks the key. So key 1 and the ultimate ciphertext will be sent to the cloud server and it will be stored in the cloud. So these are all the process for the data owner file storage. So then next comes the client side. So client has a separate authentication and the client will view the files who satisfy the specific attributes of the data owner, and then client will send request. The request will be viewed by the cloud server. So here cloud server send that key 1 and the ultimate ciphertext to the decryption server, and the decryption server will receive that, and also the key 2 will be sent from key authority to the decryption server. So by using this key, the ultimate ciphertext will be decrypted and becomes the ciphertext. So finally client will receive the ciphertext, and after updating the ciphertext, client will use the key of the data owner and decrypt and get the original content, that is the plain text. Then comes the running procedure of our process, a collaborative key management protocol in ciphertext policy attribute-based encryption for cloud data sharing. So let us run the process. So first we have to run the home page. So this is the home page of our process. So here is the registration and the login page for the both data own. So let us register for the data owner process. So I'm selecting data owner, give any name. So here is the attribute which should be satisfy the client and the owner. So here I'm selecting and giving password. So the registration was successful for data owner. So now login as the data owner. So login was success. Here I am going to select the file. So here is the content of the file. So then we have to upload the process. So the file was uploaded to the cloud server. So then this request was sent to the cloud server. So first then we have to log in as a cloud server. This file. Then we have to run key authority. Then we have to run key authority. So the requested file will be viewed by the key authority. So this was the uploaded file. And here key authority will generate key, and by using the generated key, the file content will be re-encrypted and stored to the cloud server. So the process was the file was saved to the cloud server. So then cloud. So here we are going to process the data owner process. So here it will show the file which is re-encrypted by the key authority. So this is the part of a key. This will be stored to the cloud server. The file stored to the cloud server successfully. So then comes the client process. So here we are going to register for the client. So the register was successful. So the person was registered as client. So here the doctor's file will not be viewed here. So here I'm sending request. So the request was sent to the cloud server. So if you check the status, it will be in request. So here we have to again run the cloud. So here client process. We have to view the request, and here we have to send the decryption server. So forward it to the decryption server. So the decryption server will view the request and get the content and the key. So this is the two. This is a single key which is splitted, and this is the ultimate ciphertext. So here we have to decrypt it. So here we had obtained the ciphertext, and then we have to send to the client. So the first send to the client. So check status sent. So here we got the key and get the content, that is the ciphertext. Here decrypted. So the file was decrypted successfully. So that's all about the process. Thank you.